Welcome to the first lecture. In this lecture, we'll start with some motivation for the exciting design problems we're going to solve throughout the course. Then we'll talk about three very important concepts that every software architect needs to understand to be successful in large-scale system design. And finally, we'll talk about the process we're going to follow to solve every large-scale design problem, no matter how ambiguous or scary it may seem initially. So first, let's get some motivation and discuss the plan for the following lectures. This course is unlike any other course you've taken that teaches only individual building blocks, algorithms, or technologies in isolation. Instead, this course is about applying all that knowledge to design entire real-life systems, similar to those that already exist in the real world and are used by millions of users daily. Unfortunately, most engineers never get to design such large-scale systems. That is why even the best engineers often struggle during system design interviews and large projects that require a significant upfront design. So this course will be an invaluable experience to boost your confidence as well as develop the muscle memory and the intuition behind this process. In each section, we'll tackle a new and exciting design problem, and we'll work together to narrow its scope and produce a robust and clean software architecture diagram and a well-defined API. Before we get into the actual process we're going to follow, I want to talk briefly about the software architect's mindset that you need to have to be successful with system design. The first important thing to understand is the concept of abstraction. When cooking a dish, you're likely thinking about the ingredients and their proportions and not the molecular structure of each type of food or spice in the recipe. Similarly, when a driver is driving a car or a pilot is flying a plane, they rely on the abstraction of the steering wheel, buttons, and dashboard they're provided with, and they wouldn't be able to do anything if they had to think about all the complexity involved in every move they make. In computer science, abstractions are also extremely important. If we had to understand every implementation detail of every method or library we use, or if we had to think about the flow of every bit in the CPU anytime we implement a method in a high-level programming language, we wouldn't be able to build anything. When working through system design problems, it's the same story. In order for us to design an entire system on a scale of a company that employs hundreds or thousands of full-time engineers and reaches millions of users daily, we also need to go to a higher level abstraction. And even as we progress through the design process and go deeper into certain parts of the system, we still need to stay on the abstraction level of a system and not its low-level implementation. Otherwise, we'd easily get distracted by details, lose sight of the big picture, and be unable to reach the goal we're trying to accomplish. The second important concept that any successful software architect needs to understand is every system is unique and different from the one you designed before. This is why techniques like memorization or blind copy-pasting of existing solutions just don't work in system design. In many cases, changing just one requirement can greatly affect the entire design and therefore its software architecture. This requires us to work methodically, think throughout the entire process, and make the right trade-offs at the right moments in the design. At the same time, there are quite a few common architectural patterns which are solutions to smaller problems that can really help us save time. So we'll see how to apply those patterns in practice throughout the course. The third important concept is that system design never has one correct or optimal solution. Unlike in programming, for example, where we can easily verify the correctness of our solution through unit tests, or in algorithms, which we can prove to be correct and optimal mathematically, in system design, there is never one correct answer. There can be bad solutions, there can be good solutions, and there can be even better solutions. And we can also have multiple different but equally good solutions. But there's never only one obvious solution. So experience and following the right process will maximize the chances of a successful design. So now that we got some high-level motivation, let's talk concretely about the 5-step design process we're going to follow. The first step in our design process will always be gathering the functional requirements. Since large-scale systems are very complex, there's always a lot of ambiguity when the problem is presented to us by the client, our manager, or our interviewer. This process always involves investigation and asking questions to ensure that we understand how our system behaves. During this stage, we also narrow down the scope of our problem. This means understanding what the system needs to do, what it doesn't need to do, and what parts of the system are already given to us as an external API or an internal service, and we don't need to worry about designing them ourselves. Arguably, this step is the most critical part of our design, because if we get it wrong, we will waste a lot of time solving the wrong problem. The next step in our design process is capturing the non-functional requirements for the system. This part is critical to ensure our system has the qualities our client expects. In other words, we want to ensure that our system can produce the desired behavior not just in general, but for the given workload and context. There are many quality attributes that need to be considered for a real system, but in this course, we will mainly focus on scalability, high availability, and performance. Otherwise, if we try to address every possible quality attribute, such as security, observability, profitability, and so on, each design would take us 10 hours, and in the end, we wouldn't remember anything. The next step in our process is defining our system's API and capturing the sequence of events. The type of diagram we're going to use for this process is called a sequence diagram. Using this diagram, we will ensure that all the use cases in our system are covered, so we don't miss any critical step or behavior. And once we finish this diagram, our API will naturally present itself to us in every interaction between our users and our system. The fourth design step is to address our functional requirements and create a software architecture diagram matching our API. This involves defining the architectural style we're going to follow, the flow of network requests from the client to the relevant services, and all the details about what data we're going to store and how we want to store it. In this step, we mainly focus on the system's functionality while keeping the non-functional requirements only in the back of our minds. Finally, in the last step, we finalize our software architecture to meet all the non-functional requirements, which we gathered in the second step of our design. This may involve adding additional components, eliminating potential single points of failure or performance bottlenecks, and optimizing certain critical parts of our system using different data sharding or processing techniques, software architecture patterns, and non-trivial and specialized data structures or algorithms, all to ensure we handle user requests and store our data in the most efficient way for our specific use case. So by the end of this process, we have everything we need to choose our technologies and implement the system if we want to. It's interesting to notice that the first 3 steps in our process define our system from different angles externally as a black box. And in the final two steps, when our system is well defined externally, we go down one level of abstraction and fill in all the details to fulfill those functional and non-functional requirements in the system's API. If this process seems a bit abstract to you, don't worry. Once we apply it to a real problem even once, you'll be amazed at how simple and yet powerful this process can be. So with that out of the way, let's go ahead and jump into our first system design problem. But before we do that, let's quickly summarize what we learned in this lecture. After getting an introduction and motivation to what we're going to be doing in the next lectures, we covered three important concepts that every software architect needs to understand. The first one was the concept of abstraction and the importance of staying within the appropriate level of abstraction to design every large and complex system. The second was the uniqueness of each design problem, which requires us to think, make trade-offs, and avoid blind duplication or solution copy-pasting, since it simply doesn't work in system design. And the last concept was the fact that there is never one correct and optimal solution to a design problem. So it's all about getting experience, following the right process, and making the right trade-offs at the right moments in the design. After that, we discussed the 5-step process, which includes gathering the functional requirements, capturing all the non-functional requirements, defining our system's API, addressing the functional requirements with a high-level architecture diagram, and finally, optimize our system and address all the non-functional requirements. I'll see you guys in the next lecture.